Hi, I'm Praval, and I will be going over building for intermediate robotics. Today, I will be discussing the features and functions of different parts and components you'll find when you are building. I will also talk about the implementation of these parts when building. The first main category of building parts are structural components. These are used to create a specific shape or form for your robot. They are used in almost every system in your robot, from your drivetrain, lift, shooter, and much more. The first most used is the C-channel. The C-channel is shown in the leftmost picture. It gets the name C-channel from its look. If you looked at it in a certain direction, you could see it kind of makes the shape of a C. These C-channels are measured using the number of holes it has running across it. So you would go up there and then you count 1, 2, 3, and so forth. If you observe the C-channel carefully, you can see it has notches. They're right there. The notches are there every 5 holes, so every 5 holes you'll see a notch. These notches can be used as an easier way to determine the distance. So instead of counting counting every single hole, you can just count each notch. Another important feature is for cutting. The C channels are only sold in 25 hole and 35 hole increments. So if you wanted to cut like say 10 holes from a 25 hole C channel, you could just use the notches to count it and then cut it on the notch using a hacksaw. So that would be 2 notches. Since 5 plus 5 is 10, that would be 2 notches. You cut it on the notch. It'd make it easier with the hacksaw. And the C channels are also sold in different width variants. There are 3 width variants. One of them is 2 hole, which you can see up there. It's 2 holes across. They also come in 3 hole and 5 hole increments, which is 3 holes across and 5 holes across. The next structural component is the L channel. It is called the L channel because it makes like an L shape, like if you held it in that certain direction, like right there. I would say that they're kind of like C channels, except they're slightly different. As you can see, the L channel only has a bend in one side, while the C channel has a bend in both sides. L channels are also referred to angles because they create a 90-degree angle as well. The next structural part is the plate. I would say the plate is the second most used structural component, and I would say it's the most versatile. With the C channel, they're both the most versatile. Like the plate is flat. We don't see any bends like the C channel or the L channel does. And if you look even closer, you can see that there's a notch on almost every hole. So I would say that the plate is actually the most easier to cut and put in any shape. You can cut it into small squares or like a rectangle if you wanted to. If you look to the rightmost, you could see that there's something called a bar. The bar is kind of like the plate. It looks like it's just one strip from the plate. But it has its own unique property, and that property is being able to bend. So you could bend the C channel, not the C channel, I'm sorry, but the bar without breaking, and you can make different curves and bends that you couldn't do with any of these other metal parts. All of these structural components come in 2 major variants, which is aluminum and steel. Um, Aluminum is the most commonly used, and there are 2 major differences between aluminum and steel. Number 1 is that aluminum is less heavy than steel, and second, aluminum is way easier to cut than steel. So, for example, for aluminum, you could use a non-power tool like a hacksaw, like I was talking about with the C channels, and cut it. But with steel, you would have to use like a power tool to cut it. But steel is good on its own regards. It's really heavy, so it's good for like when you want to weigh something down. So for example, if you had a drivetrain and it had a like large lift, and when you lifted it over it would tip, you could put steel C channels instead of aluminum ones to weigh it down so it can prevent it from tipping. Continuing with the structural components, we have bearings. Um, Bearings are used they go hand in hand with the drive shafts, which we'll get into when we go into the motion section. But basically, you'd put a shaft through a bearing when you put it through a motor and spacers and all of those, which we'll get to soon. So the bearing has 2 variants: the pillow bearing and the flat bearing. As you can see, you can see the flat bearing right there. It's flat, as the name suggests. You would usually you could screw the bearing in to your structural component like a C channel, and the shaft as well would go through that C channel. It would go through the holes of the C channel as well as going through the bearing. But with the pillow bearing, as you can see, it has this like sort of hump. It doesn't have the hole going down like the flat bearing does. It has it going across. So you screw in the bearing to the structural component like a C channel, but instead of going through the C channel, we see that it would go across it. It would not it wouldn't like intersect into it. Um, these bearings also have these two bearings also have two variants in of itself. It has a high strength version and a regular version. The high strength and regular refers to the shaft itself. High strength shafts are thicker, so that's why the ones with the wider holes are considered high strength because it could fit the high strength shaft. The next structural component we will be talking about is nuts. Nuts are used to make sure the screws are fastened tightly, nothing moves around, comes off during competition. The most commonly used nut is the Kep's nut. You can tell it's Kep's nut because it has these like sort of spikes or like grooves on top of the regular nut. So for this one, it's fairly simple. You don't even need pliers or you don't need a wrench to put it in. You can just use your finger, put your finger on the bottom and then screw it on top. You screw it on top. The next variant of the nut that is most commonly used, the second most commonly used is the lock nut. Lock nut is used when you want motion. So if you wanted something to move and be in place, you would use a lock nut. But with the lock nut, you would need to use a pair of pliers or a wrench to hold it down when you're screwing it in. So, for example, you would use a lock nut in the situation of the joints on a lift, because you know that a lift has to move up and down. You wouldn't use a Kep's nut because the Kep's nut would keep it stiff and it wouldn't move. Lock nut would give you that motion while keeping it in. The next structural part we're going to talk about is the hex drive screws. They come in two variants, the 832 and the 632. The difference between them is that the 632 is smaller than the 832. The 832 requires a 332nd screwdriver, and a 632 requires a 5/64th screwdriver. The 332nd screwdriver is usually bigger than the 5/64th screwdriver, and in general, you would mostly use 832 and 332nd more than you would use the other screw or the other screwdriver because they usually make the 832s more than the 632. You use the 632 on some occasions for some parts, but 832 is the most commonly used. Continuing with the structural parts, we have spacers. Spacers come in many various sizes. They're put on like to the drive shafts to create like distancing and to keep it secured. They also come in another variant, which is the high strength. As I said with the bearings, they have a wider hole to accommodate the thicker drive shaft. Another component is the washer. You could see it's kind of similar to the spacer, except washers are usually metal and they're usually very small compared to the spacers. I would say whenever you want to create distance, you use spacers first, and then for like if you're like a little bit off, you use washers and try to get as close to the distance as you want. So spacers usually come first, and then you go for washers. Another important structural component is the shaft collar. So after you put on all your spacers, your washers, and everything you need, you want to fasten it using this shaft collar. So it's a collar that you put it on your shaft, and it has this screw right here. What you would do is for this situation, you would need a 5/64th. This is one of the rare occasions where this is a 632 screw, and you would need a 5/64th screwdriver. So you would put it on your shaft and screw it in so that none of your spacers and your washers, your other items wouldn't move on shaft. They also have a high strength version, which is shown on the leftmost side. You can see that the difference between these two is this one actually uses a regular screw, which is the 832 screw, and if you look closely, it's actually a lock nut. So for the lock nut, as I said before, you would need a pair of pliers or a wrench to hold it while you screw it in. The next section is power. There are four major components for power, and these are necessary for your robot to function. And the most important out of all of these is the V5 robot brain. This contains all the programs you need that will help you run your robot, and you can access them by, it's a touchscreen, so you can access them by touching it and picking your program. You can also see that there's these little sockets in the brain. That's where you connect your motors and your radio and all your stuff and all the stuff that you need to connect that is part of your robot. Another part you see is the battery. The battery is what a typical battery is. It gives power to the brain. You connect it using a clip. It's also rechargeable, so you have to charge it every now and then you put it back and clip it back to the robot brain. Next important part is the controller. This allows you to drive your robot around. It's programmable, so that's what programmers usually focus on, these components of the robot to help program. This is like the most commonly used. The next part is the radio. The radio is like the intermediate between the brain and the controller. It gives the connection between both of them, so it's easier to use. It's also it uses the same wire connection as the motors do, so you just plug it into those sockets that you see there. One important thing about the brain is that you can actually see every single motor and see if it's connected and run each individual motor. That's one of the specialties with this brain. You could see which motor is, if it's working, if it's not working, if it's doing what you want to, and it gives you more ease of accessibility and see what, if something's going right or wrong with your building. The next section is motion. So the major part of motion is the motor. This is called the V5 smart motor. So you can see it has a socket on the side. You'd put a wire to that, and then the robot brain, which we saw earlier. The V5 smart motor has 3 cartridges, as you can see in this picture. So if you want to access the cartridge, you can see that there's these small screws, which are the 632s that we're talking about. This is the other rare instance where you would need the 5/64th screwdriver to open it up. When you open it up, you see that there's this little colored cartridge. Each cartridge color is different, so you can get a 36:1 ratio cartridge, an 18:1, and a 6:1. The 6:1 will have the highest RPM, while the 36:1 will have the lowest RPM. And so in order for your motor to function, you would need a drive shaft. There's 2 drive shafts, which I was talking about. There's the high strength and the regular version. As I said earlier, the high strength shaft will be more thicker, and the regular shaft will be in your regular size. The regular shaft advantage is it can fit through almost any hole, like any C channel hole, plate hole, or bar hole, or L channel hole. It goes directly to the motor, and it has its own spacers and everything. A disadvantage is if you put it, it may bend or break easily. An advantage with the high strength is that it won't bend or break easily. It's more strong, it's more firm. But a disadvantage is it's really thick, so it wouldn't fit in your regular structural, like C channel, L channel bar or plate. You would actually have to drill another hole in that C channel in order for it to go through. So I would say if you're using these, you should use like a pillow bearing, because as I said, the pillow bearing does not make sure that the drive shaft doesn't make contact with the actual structural component. It goes across it, not into it, as opposed to the flat bearing where it would go straight through it. But if you're having trouble with that, they also sell high strength bearings. But keep in mind that you have to drill holes for you to use them. Continuing on with motion, we have 2 other major components, gears and sprockets. These can sometimes be confused, but we'll talk about them here. So in the middle picture, we see a gear. When two of these have to be in direct contact to form a gear train, so 2 or 3, they come in all these different sizes. The T stands for the tooth. So right here, this is the biggest one. This is an 84 tooth gear. You just count the little edges it has to see how many teeth it has. So the sprocket are similar to gears, but as you can see, it has more of a little curve than the gears does, and that's to accommodate the wire, as you see here. So what's different is sprockets don't need direct contact with another sprocket, as the gears have to have direct contact. You can have sprocket on one end and another sprocket on the other end, and then chain it with a wire. An example of where sprockets would be used is usually on the drivetrain. So instead of having four motors power each wheel, you can have one motor power one side and the other motor power the other side. Have two shafts and a sprocket and connect it to the gear. Usually that's what people do, and it conserves motors. The last thing I'm going to talk about is the wheels. The wheels are probably the most important part of a drivetrain. It allows your drivetrain to function properly as it's supposed to. Up here, that's the standard wheel. It does what your standard wheel needs to do. It can move forward, it can go back, it can turn left, it can turn right. I wouldn't say it's the most commonly used. In my opinion, I think the most commonly used would be the omni wheels, which are shown below. The difference, if you look at it, you can see these little mini rollers. They're like kind of rubbery. Um, they can spin. So they can do what your standard wheel does. They can go forward, backwards, turn right, and turn left. But in some configurations, for example, an H drive configuration, which is two wheels on the left, two wheels on the right, and a wheel in the middle. If you program it in a correct way, it can allow your robot to move sideways, which is called strafing. A lot of teams like to use that. It allows you to center your robot, and it's really useful in competitions. The next wheel is macadam wheels. If you look at it, you can see there's that same type of rubber material, but it's in an angle. They're angled rollers, not like the Omni wheel, which has the straight rollers. But the unique thing about this is it could move forward, backwards, turn left, and turn right, like all the other wheels do. But it could move sideways in its normal configuration. You don't have to have a wheel in the middle or any other special stuff. It can do it by itself. But one of the complaints that are usually given to the mechanical wheels are that they're really hard to program, and sometimes they're not as properly functioning as the Omni wheels would be. So each of them has their own advantages and disadvantages. It's looking at what your robot needs and how all you can implement all these components and make sure you have a good robot. I hope you learned something from this video, and thank you.